A school district purchases a high-volume printer, copier, and scanner for $15,000. After 10 years, the equipment will have to be replaced. Its value at that time is expected to be $3,000. Write a linear equation giving the value V of the equipment during the 10 years it will be in use. Let T be the number of years after purchase. In the beginning, the school purchases the printer, copier, scanner for $15,000, so no time has elapsed. After 10 years, the machine has depreciated to a value of $3,000. So we're asked to find a linear equation representing value during the number of years T. So again, I'm going to set up ordered pairs as T and V. First, let's find a slope. 3,000 minus 15,000 over 10 minus 0. So there's $12,000 in loss of value over the 10-year period for an average of $1,200 depreciation per year. The original purchase price is your y-intercept. It's the initial value. So that's going to go in when we write slope-intercept form. Excuse me. That will be our b value. We just calculated m, our slope. So we have y equals negative 1,200x plus 15,000. Over to the bottom right, you'll see a graph that I sketched in class, sketching our initial value, connecting it with our ending value. So from 0, 15,000 to 10, 3,000, I just eyeballed this. Eventually, there would be so many years that the machine would be worth nothing, but after 10 years, we were told 3,000. So this segment can be represented with V equals negative 1,200t, that was our slope or depreciation, plus 15,000, that was our initial value. A roofing contractor purchases a shingle delivery truck with a shingle elevator for $37,950. The vehicle requires an average expenditure of $6.50 per hour for fuel and maintenance, and the operator is paid $16.50 per hour. Write a linear equation given the cost C of operating this equipment for T hours. Include the purchase cost of the equipment. Okay, so to run the machine, fuel and maintenance, that's $6.50 per hour on average. The operator is paid $16.50 per hour, so both of those are per hour cost. The truck and elevator was an initial cost of $37,950. That one doesn't get a variable. That's an initial purchase, excuse me, not based on time. Combining like terms, we have 23t plus 37,950. So this equation represents the cost. That's the owner's money that they're having to put in to their business. Revenue, this is the money that's going to come in from charging their clients. Assuming that customers are charged $46 per hour of machine use, write the equation for the revenue obtained from T hours of use. So this one's real easy. $46 per hour, that's what the customers charge. This will be revenue, or the money coming in. Use the formula for profit, that's revenue minus cost, to write an equation for the profit obtained from T hours of use. Okay, so what we're going to do is profit, that's revenue, that was 46t, minus cost had two terms, 23t plus 37,950. Be sure to distribute your negative. 46t minus 23t is 23t, and then we have a minus 37,950. Use the result of Part C to find the break-even point, and that's where revenue and cost are equal. If revenue and cost are equal, then profit is 0. So we're going to find the number of hours this equipment must be used to yield a profit of $0. So we take our formula or our equation from Part C, replace profit with 0, add 37,950 to both sides, divide by 23, and we get T equals 1,650 hours. After this time, there will be a profit. The revenue will be more than the cost. And let's do a short intro to solving a system of equation by substitution. The next video I'll do a little more formal job of it, but in class we had some extra time, so I wanted to go ahead and at least get you an initial dose of solving systems using substitution. And we're going to do some applications of these later as well. Okay, a system of equations and two variables. We have two equations, two unknowns, x and y. First, we're going to solve by a method of substitution, and then we'll check by graphing. So over on the left half of your screen, your first step is to pick one equation and solve for one variable. As you go through your equations, you want to try to figure out what variable would be the easiest to solve. And so I'll let you guys tell me in class. What we did was we picked the second equation and we isolated y by adding x to both sides. So step one, we picked an equation, we isolated a variable, y equals x. In step two, you go to the other equation, the one you didn't use, and replace that variable or substitute it with what you found in step one. So substitute this into the other equation. We went to the top equation, 2x plus y equals 12, and we replaced y with an x because they're equal. That'll give us 2x plus x equals 12, 3x equals 12, and that tells us that x equals 4. Well, at this point, we have half of our answer. Go back to step one and substitute in x equals 4. Well, if x equals 4, then y has to be 4. When you pair up your x and y value, 4 and 4, that actually is the intersection point of the two lines from the system in the beginning of the problem. And just as a reminder, the top equation, if we isolate y equals negative 2x plus 12. And in the second equation, y is equal to x. The top equation, that's a y-intercept of 12 and a slope of negative 2. That's this line. Y equals x, that's a slope of 1 and a y-intercept of 0. That's this line. And sure enough, they intersect at the point 4, 4. In the second system of equation, set of systems of equations, we have x minus 3y equals negative 14, x plus 2y equals 1. Again, I'll let you guys decide which equation and which variable would be the easiest to solve. You guys told me to take the second equation and isolate x. So if I subtract 2 y's, I have x equals 1 minus 2y. And that was a good move. In my opinion, that was one of the easiest to isolate. Now, the equation we haven't used was the top equation, x minus 3y equals negative 14. Replacing x with 1 minus 2y, we have 1 minus 2y minus 3y equals negative 14. Combining like terms, 1 minus 5y equals negative 14. Subtract 1, negative 5y equals negative 15. And then finally, dividing by negative 5, we get y equals 3. Go back to step 1, replace y with a 3, and that gives us x equals 1 minus 2 times 3, which is negative 5. When you pair up negative 5 and 3, you come to this location, negative 5, 3, and that's the intersection of these two lines.